I'm worried. And welcome, ladies and gentlemen. We're looking at a practice worksheet we did last night from an Algebra 2 textbook, oddly enough, but it still covers the same concepts. We're looking at problem 13. We're talking about the binomial theorem, binomial expansion, and we were able to, using kind of this formula, I wrote it in terms of combinatorics here, but this is the same as n factorial over n minus r, all factorial, r factorial, all in the denominator. I think I just said denominator really quick, and you can really tell. But anyways, let's figure out what the fourth term of this is. Let's see. So I might need some help here because it's been a while since we've done this, huh? All to the fourth. So let's see. Let's see if I can do this. So n is, oh, that's a 6. That would be helpful. Thank you. So you guys already got my back. I think I remember how to do this. So let's see. So n is the 6. Am I right? X is x. Y is 3y. Or negative 3y if you don't, I don't know. I account for the alternating signs on my own. And then r is the number of the term minus 1, was it? Okay, so we're looking for the fourth term, so r is 3. So let's plug this in. And I won't be doing a sigma of this. That would be the whole expansion. I'm just going to be plugging it in to kind of the non-sigma part for this very particular value. So let's see. So combo 6, 3 would be 6 factorial over 6 minus 3 is 3 factorial times r factorial is 3 factorial, right? Times x to the n minus r, so 6 minus 3 is 3, and times y. I guess, you know what? I can't do the alternating sign trick if I don't know what term I'm on. I mean, I could count it and figure it out. So maybe it would make sense to have this be negative in this case, and I'm raising this to the r. So yeah, you could define that as negative if you wanted.
I didn't know r is minus 1.
Yeah, so it's r equals number term minus 1. I think we had a problem where we did that last week.
Yeah, I forgot to do it.
But yeah, that's a stumbling block right there if there was one for these problems. So let's see, this is the same as 6 times 5 times 4 times 3 factorial all over 3 times 2 times 3 factorial. And this is x to the third. Negative 3 to the third will be, what, negative 27? Maintains its negativity. Something like that. I don't know. I just have the parentheses there so it's clear that this is multiplication and not subtracting 27y cubed. So let's cancel out what we can. 3 facty, 3 facty. 3 times 2 is 6. So I'm going to have 20 times negative 27 is negative 540 if I believe the answer up above me. And x cubed, y cubed. So if you got this wrong, likely the r might have been your culprit. It's definitely a potential error. And if I didn't define y as being negative 3y, you could have kind of figured out the sign. The first term's positive, negative, positive, negative. So you could realize, oh, fourth term neg. And you could have, figure it out from there. So even terms are negative, odd terms are positive if you have a minus sign in your binomial. How about one more question, if there are any?
Not that I realized the odd problem.
What's the Pascal triangle?
The Pascal's triangle is on the
On the little half sheet.
sheet. Yeah, it's also found in the book. Let's see, find the sixth element. Let's see. Man, this is what happens when we haven't met for like 5 days. Even I don't remember how to do this. Let's see. So sixth element of the 10th row. Now, we've got to figure out what do they mean by 10th row. I think they probably mean this row, 1, 9, whatever 9, 1. I'm guessing that is the 10th row because the first row is the one that's just a single 1. Okay? So if I want the 6th element, all right, so that means that's like the 6th term. So r is equal to 6 minus 1 or 5. N is equal to 9 in this case. And these terms in the Pascal's triangle are the coefficients of a binomial expansion. Well, before unless you have like y equals negative 3y or something like that, then that messes up your coefficient. But it's your kind of starting coefficients for the expansion. So I believe I could just answer this by doing combo 9, 5, if I'm not mistaken. I hope. So that's 9 times 8 times 7 times 6 times 5 factorial. Over 9 minus 5 is 4 factorial, so that's 4 times 3 times 2 times, and then r factorial is 5 factorial. And I preemptively stopped there so I could swipe. Let's see, 3 times 2 is 6. 4 goes into 8 twice. So 9 times 2 is 18 times 7. 70 plus 56. What?
Oh.
63. 4 times 2 is 126.
Yeah, 63 times 2, 120. Whichever way you end up doing that.
Or you could have gone on the little lovely sheet.
Yeah, that's how we did it.
Yeah, but I want you to be able to generate those without the sheet. So for instance, what if I asked you for the, 21st element in the 100th row of Pascal's triangle?
You could draw out the whole triangle.
That would take a long time. Actually, your terms would end up being so wide, your triangle would get excessively wider. Like you'd have to keep accounting for terms that have more and more digits in them. It'd end up being a little bit difficult to do. So yeah, R is one less than the term you're on, and term and element is kind of the same thing as far as Pascal's goes. So any other questions on this?
Not that I understand R. No, really.
Yeah, excellent. So R is the trickster. And I think we're good. Goodbye, Internet.